Yes. Now we are discussing failures of classical free electron theory. These failures only explained by quantum free electron theory as a success. Okay. Here there are so many failures are there in classical theory, but here we are discussing only three cases. One is specific heat, and other is a temperature dependence, and the last one dependence of electron concentration. Okay, first we will go for the specific heat. See, classical theory failed to explain many experimental concepts, among which the most important ones we are discussing here, that is, one is specific heat, second one is temperature dependence of electrical conductivity, and the last one is electron concentration dependence on electrical conductivity. First go for the specific heat. Specific heat andre the amount of energy is required, that is amount of heat is required to increase the temperature of 1 degree Celsius with respect to the unit volume. So ಒಂದು ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಅಲ್ಲಿ ಎಷ್ಟು ಹೀಟ್ ನಮಗೆ ಬೇಕಾಗುತ್ತೆ 1 degree ಟೆಂಪರೇಚರ್ ನ ರೈಸ್ ಮಾಡೋದಕ್ಕೆ 1 degree Celsius. See, here we are considering it is a gas model. Classical theory we are explaining through a gas model. The molar specific heat of a gas at constant. So that expression they have given. This classical theory expression they have given this because this is applied to the gas molecules. So where Cv represent the molar specific heat at constant volume, that is equal to 3/2 R. Here R represent the universal gas constant. The value of the universal gas constant, that is 8.314. Okay. So this is the expression given by the classical free electron theory to explain the specific heat. But experimentally it is not like that. See, as per the theory, free electrons are treated as gas molecules. That above equation must applicable for free electrons also. But experimentally it was found that the specific heat of a metal by conduction electron was Cv is equal to 10 to the minus 4 R into T. So this expression is from the experimental result. Idu experiment in the equation na madidare. Okay, so this is a theoretical expression given by the classical theory, and this is the expression given by the experimental values. And look at this, both are different here. And look at this. Here 3/2 value na ನೀವು calculate ಮಾಡಿದ್ರೆ it is around 1 point something. It is more. But here 10 to the minus 4 means it is a very small value. So there is a difference between these two constant values. And R and R both are same. So means it is depending on the universal gas constant. And look at here. There is a temperature term. Illi temperature term ಕಾಣಿಸ್ತಾ ಇದೆ ಯಾವುದರಲ್ಲಿ experimental value ನಲ್ಲಿ. But look at here, in a theoretical value there is no temperature term. ಅಂದ್ರೆ ಇವರ ಪ್ರಕಾರ that specific heat is not at all depending on temperature. Okay, but experimentally it is directly depending on the temperature. As temperature increases, specific heat also increases. So this is the main failure of the classical theory. Nodi temperature ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ ಅಂತ ಅವರು ಹೇಳ್ತಾರೆ, but experimentally it is not like that. Which is not only far lower than the expected value but also shows a dependence on temperature which is contrary to the theory. ಅಂದ್ರೆ ಅವರು ಕೊಟ್ಟಿರುವಂತ ಥಿಯರಿಟಿಕಲ್ ವ್ಯಾಲ್ಯೂ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ವ್ಯಾಲ್ಯೂ ಜೊತೆ ಮ್ಯಾಚ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ ಇಟ್ ಈಸ್ ಅ ಫೇಲ್ಯೂರ್. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ ಫೇಲ್ಯೂರ್ ಆಫ್ ದಿ ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ, ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್. ಗೋ ಫಾರ್ ದಿ ಸೆಕೆಂಡ್ ಒನ್, ಟೆಂಪರೇಚರ್ ಡಿಪೆಂಡೆನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಹೌ ಟೆಂಪರೇಚರ್ ಈಸ್ ಡಿಪೆಂಡೆಂಟ್ ಆನ್ ದಿ ಕಂಡಕ್ಟಿವಿಟಿ. ಅಂದ್ರೆ ಆಸ್ ಟೆಂಪರೇಚರ್ ವೇರಿಯೇಷನ್ ಯಾವ ತರ ಆದ್ರೆ ಕಂಡಕ್ಟಿವಿಟಿ ಯಾವ ತರ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ. Now, according to the classical free electron theory, the average kinetic energy, this expression was taken from assumption. Second assumption alli ee ondu expression na tagondidivi, that is half mv square is equal to 3/2 kT. This is the kinetic energy, it is equal to 3/2 kT. So if you remove this denominator, 2 cancel madidre namage thermal velocity, v represent the thermal velocity, v is equal to square root of 3 kT by m anta barutte. ನೋಡಿ ಇಲ್ಲಿ ವೆಲಾಸಿಟಿ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ರೂಟ್. ಈ ಕಾನ್ಸ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ನ ತೆಗೆದ್ರೆ ನಮಗೆ ಟೆಂಪರೇಚರ್ directly proportional to root t birth, okay, velocity. But from the mean collision time expression gottalva, velocity is distance by time, so time is inversely proportional to velocity. So mean collision time is inversely proportional to velocity andre, so that velocity is directly proportional to root t. So in the same way ee expression inda ನಾವು ಏನು ಬರಿಬಹುದು ಅಂದ್ರೆ mean collision time is inversely proportional to root t ಅಂತ ಬರಿಬಹುದು. So why we are doing this relation means we are showing the dependence of temperature on electrical conductivity. So you know, from the expression of electrical conductivity, sigma is equal to n e square tau divided by n. So this is the electrical conductivity expression from the classical theory. See, look at here, the sigma is directly proportional to mean collision time. Sigma is directly proportional to mean collision time. That mean collision time is inversely proportional to root t. So using this expression we are writing sigma is inversely proportional to 1 by root t. So this is from the classical theory. Okay. Now coming to the experimental result. So it has been observed that experimentally for the metals the electron conductivity, electrical conductivity sigma is inversely proportional to t. ನೋಡಿ ಇದು theoretical value ಆದರೆ ಇದು experimental value ಆಗುತ್ತೆ. So look at the difference here. The theoretical value is showing it is inversely proportional to 1 by root t, but experimentally it is showing it is inversely proportional to 1 by t. So there is a difference here. T root t andre t power half ಆಗುತ್ತೆ, but this is t power 1. So it is half of this. So there is a contrary in the statement and it is not at all matching here. Experimental value gu matte theoretical value gu match ಆಗ್ತಾ ಇಲ್ಲ, hence it is a failure. Okay, so that is the second failure of classical theory, temperature dependence on electrical conductivity. And go for the last one, dependence of electrical conductivity on electron concentration. Look at the expression of electrical conductivity of classical theory. Sigma is equal to n square tau divided by m, where n represent the electron concentration. The electron concentration ಯಾವ ತರ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಸಿಗ್ಮಾಗೆ ಅಂದ್ರೆ it is directly proportional. Sigma is directly proportional to n. Means what it means electron concentration, as number of electrons increases the conductivity should also increase. Of course we can agree electrons ಜಾಸ್ತಿ ಆದ್ರೆ conductivity ಜಾಸ್ತಿ ಆಗಬೇಕು ಅಂತ ನಮ್ಮ assumption ಇರುತ್ತೆ. But look at here, surprisingly ಎಲ್ಲಾ metals ಗೂ ಇದು apply ಆಗಬೇಕು, but some of the metals are contrary to this. How means, you know, some of the divalent metals and trivalent metals, you know, monovalent, divalent and trivalent. Monovalent means only one valence electrons should be there, divalent means two valence electrons, trivalent means three valence electrons. ಅಂದ್ರೆ ಮೂರು outer most electrons ಇರುತ್ತೆ trivalent ಅಲ್ಲಿ, divalent ಅಲ್ಲಿ ಎರಡು valence outer most electrons ಇರುತ್ತೆ, monovalent ಅಲ್ಲಿ only one. Okay, so they have given some of the examples for divalent metals like beryllium, cadmium, zinc and trivalent aluminum, indium and some of the other examples. They are showing lower conductivity than the metals which are monovalent like copper, silver and gold. Nodi, beryllium, cadmium, zinc, these are all divalent. Aluminum and indium are trivalent. They have more valence electrons. Means it should be expected as number of electrons increases the conductivity should increase. But experimentally it is not like that. Nodi, copper has a very good conductor, silver has very good conductor, even gold also. But they have less valence electrons. They have monovalent electrons. Only one single valence electron will be there. So they are giving a superior conductivity compared to the divalent and trivalent atoms. Okay. So on the other hand, lower electron concentrated metals are higher conductivity than the metals with higher concentration, vice versa. And look at the examples here. ಇಲ್ಲಿ ನೋಡಿ example ತೋರಿಸಿದ್ದೀನಿ ಇನ್ನೊಂದು monovalent and conductivity. Okay, monovalent metals, ಕಾಪರ್ದು conductivity ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡಿ 5.88 into 10 power 7 ohm meter and gold is 6.30 into 10 power 7. But go for the divalent and trivalent. We have a zinc, it is a divalent metal, means more number of free electrons will be there, and look at the conductivity, it is 1.09 into 10 power 7. and even cadmium has a divalent, and its value is 0.15 into 10. It is very less than this copper and gold. Look at the trivalent. Aluminium 3.65 into 10 power 7. Gallium is 0.67 into 10 power 7. So they have more number of free electrons, but they have less conductivity. Okay. So what it states, ಇದರಿಂದ ನಮ್ಗೆ ಏನು ಗೊತ್ತಾಗುತ್ತೆ ಅಂದರೆ ದಟ್ ಸಿಗ್ಮಾ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಎನ್. ಎಲೆಕ್ಟ್ರಾನ್ಸು ಜಾಸ್ತಿ ಆದಂಗೆ ಕಂಡಕ್ಟಿವಿಟಿ ಜಾಸ್ತಿ ಆಗಬೇಕು, ಬಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲಿ ಇದು ಆ ಥರ ಆಗ್ತಾ ಇಲ್ಲ, ಎಲ್ಲ ಮೆಟಲ್ಸ್ಗೂ ಇದು ಅಪ್ಲೈ ಆಗ್ತಿಲ್ಲ. ಸೊ ದೆರ್ ಈಸ್ ಎ ಸಮ್ ರೀಸನ್ ಬಿಹೈಂಡ್ ದಿಸ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ಡ್ ಬೈ ಕ್ಲಾಸಿಕಲ್ ಥಿಯರಿ. ಸೊ ಈ ಕಾನ್ಸೆಪ್ಟ್ನ ಅದು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದ್ರಲ್ಲಿ ಫೇಲ್ ಆಗುತ್ತೆ ಒನ್ಸ್ ಅಗೇನ್. ಸೊ ದೀಸ್ ಆರ್ ದಿ 3 failures. One is specific heat, second is temperature dependence on electrical conductivity, and the third one is electron concentration. ಈ 3 ಪಾಯಿಂಟ್ಸ್ ನಿಮಗೆ ಜ್ಞಾಪಕ ಇದ್ರೆ ಕ್ವಾಂಟಮ್ ಥಿಯರಿ ಸಕ್ಸಸ್ ಅಲ್ಲಿ ಇದು ತುಂಬಾ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಸಿಮಿಲರ್. ಇಲ್ಲಿ ಫೇಲ್ಯೂರ್ಸ್ ಏನಿದೆ ಅಲ್ಲಿ ಸಕ್ಸಸ್ ಅಂತ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೇವೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಯು ವಿಲ್ ಗೋ ಫಾರ್ ದಿ ಅಸಂಪ್ಷನ್ಸ್ ಆಫ್ ಕ್ವಾಂಟಮ್ ಥಿಯರಿ. I hope you remember the assumptions of classical theory. 4 points ittu, illu 4 points ide. Only the first 2 assumptions will change here. So look at the first assumption. The energy values of the conduction electrons are quantized. The allowed energy values are realized in terms of set of energy levels. Andre ee electrons enide aa electrons energy values quantized agirutte. Means there should be a specific energy level should be there. That energy levels will be at certain energy values. Okay, adu energy values yavattu continuous irodilla. They have only a specific amount of energies will be there. So electrons will fill the specific energy orbits. You know the electron configuration SPDF. S fill admele that is p orbital will fill, then d orbital, then f orbital. Like that, there will be a quantized energy levels will be there. Continuous energy irodilla, quantized agirutte anta ಹೇಳ್ತಾರೆ. That is the first assumption. And go for the second assumption. The distribution of electrons in a various energy levels is according to the Pauli's exclusion principle. So filling up of that energy orbitals is according to the Pauli's exclusion principle. Pauli's exclusion principle prakara electrons fill ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಒಂದೊಂದು ಆರ್ಬಿಟ್ ಗೂ. So what is this Pauli's exclusion principle says? You know, the statement is like this: no 2 electrons can have the same set of 4 quantum numbers, which means ಒಂದೊಂದು ಆರ್ಬಿಟ್ only it occupies 2 electrons. Its capacity is only 2 electrons, and it will fill only 2 electrons. That is, 1 electron with plus of spin and other electron will be minus of spin. Then after filling the first energy level only, it will go to the second orbit, like that. Okay, that is the Pauli's exclusion principle. Then remaining third and fourth are common. You know that the electric potential produced by the metals will be common, that is constant throughout the metal, and hence it is neglected, the third one. Okay, the free electron travel in a constant potential inside the metal but stay confined within its boundaries, so hence it is neglected. So as we have already discussed in classical theory assumption. And the last one is common. The attraction and repulsion between the charge carriers are considered to be neglected. ನೋಡಿ, ಥರ್ಡ್ ಮತ್ತೆ ಫೋರ್ತ್ ಪಾಯಿಂಟ್ ಏನಿದೆ ಇದು ಕಾಮನ್ ಇರುತ್ತೆ in both classical theory assumption and as well as quantum theory assumption, but only first 2 points will change. ಇಲ್ಲಿ ನೋಡಿ, ಇವೆರಡು ಚೇಂಜ್ ಆಗಿದೆ, ಇವೆರಡು ಕಾಮನ್ ಇದೆ, both classical theory and quantum theory. So what are the difference here? The energy values of the conduction electrons are quantized. ಅಂದ್ರೆ specific energy levels ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಮಾತ್ರ fill ಆಗುತ್ತೆ electrons, continuity ಇರೋದಿಲ್ಲ. And the second one, the distribution, that is occupation of energy levels, is according to the Pauli's exclusion principle. Okay, through this principle only they will fill the energy levels, not continuously. Okay, and the third and fourth points are common here. Okay, these are the 4 assumptions of the quantum theory. I hope you understand. Okay, thank you.